Hello everybody. In this video we are going to be looking at the solutions to the Honors Series and Parallel Circuits Practice Problems 1. Just a quick note, there are a lot of problems on this worksheet. If you're looking for the answer to a certain problem, the beginning of every problem is time-stamped, and those times are located in the description below. So you can just jump to a particular problem if you want to. But let's start with problem number 1. We have a 3 ohm resistor is connected in series to a 6 ohm resistor and a 12 volt battery. What is the current in each of the resistors, and what is the voltage drop across each resistor? Let's take a look at what we're given here. We're given first a 3 ohm resistor. Then our resistor 2 is 6 ohms, and the voltage of the battery is 12 volts. Just a quick reminder, this is a series circuit, and that really should be the first thing you determine when you're looking at these problems. Is it a series or parallel circuit? This one being a series circuit, I know that in a series circuit, the current is going to be the same across all the resistors, and the voltage is going to be shared among the resistors. So the first thing that they are asking us to find is the current in each of the resistors. So I know that the current is the same in each of the resistors, and that's the same as the total current of the circuit. So if I can find that, I can find the current in each resistor. In order to find the total current of the circuit, I am going to need to know the equivalent resistance. And in a series circuit, the equivalent resistance is simply going to be the sum of the individual resistors. So for this circuit, I have 3 ohms plus 6 ohms, and that is going to give me an equivalent resistance of 9 ohms. Now that I know that the equivalent resistance and I know the voltage across the battery, I can use Ohm's law to find the current. So 12 volts divided by 9 ohms is going to give me a current of 1.3 amps. So I'm going to have 1.3 amps across each of the resistors. The second thing they want us to find in this problem is what is the voltage drop across each resistor. So to find the voltage across each resistor, I have to use the resistance of each resistor when I calculate that. So to find the voltage across resistor 1, I need to multiply the current 1.3 amps times the resistance of resistor 1, 3 ohms. So 1.3 amps times 3 ohms is going to give me 4 volts. For the voltage across resistor 2, I multiply my 1.3 amps times the resistance of resistor 2, and that is going to give me 8 volts. Problem 2. A 480 ohm resistor is connected in series to a 360 ohm resistor and a 120 volt power supply. What is the current in each of the resistors, and what is the voltage drop across each resistor? So this problem is going to be solved the same way the previous problem was solved. And before we go into the solution for this one, just a quick note, I am not going to be so concerned with significant figures for these problems. I want you to just get used to finding equivalent resistances and applying Ohm's law to find currents and voltages. So I'm not going to worry about significant figures for these problems. But I can guarantee you when it comes to the test that we will be worried about significant figures. So let's look at our known values for this. We have the resistance of our first resistor, 480 ohms. The resistance of the second resistor, 360 ohms. The voltage across the battery is 120 volts. So the first thing I want us to find again is the current in each of the resistors. Being a series circuit, I know that the current is going to be the same across all the resistors and across the power supply. So I need to find the equivalent resistance in order to find the current. So to find the equivalent resistance, again, it's a series circuit, so I just have to add my two resistances together. 480 ohms plus 360 ohms will give me an equivalent resistance of 840 ohms. I apply that equivalent resistance to Ohm's law to find the current, and I know the current is going to equal the voltage, 120 volts, divided by my equivalent resistance, 840 ohms, and that's going to give me a current of 0.14 amps. To find the voltage drop across each resistor, I know that I have to use the resistance of the individual resistors to find that. So to find the voltage across resistor 1, I'm going to multiply my current, 0.14 amps, times the resistance of resistor 1, 480 ohms, and that's going to give me a voltage of 68.6 volts. To find the voltage across resistor 2, I'm going to multiply my current times the resistance of resistor 2, 360 ohms, and that's going to give me 51.4 volts. Just one quick note, remember that my voltage is shared across each of the resistors. So if I take the resistance the voltage across each of my resistors, and I add them together, I should get something very, very close to the voltage of the power supply. So 68.6 plus 51.4 should equal 120. And remember, sometimes it might be off by 0.1 volts or by a small fraction because of rounding errors, things like that, but it should come to something very, very close to the voltage of the power supply. Problem 3. Two resistors with values of 3 ohms and 4 ohms are connected to a 24-volt battery as shown in the figure. Determine the readings on all 3 devices. So we are given the resistance of the first resistor at 3 ohms, the resistance of the second resistor, 4 ohms, and the voltage across the battery is 24 volts. And the 3 devices that we're talking about is an amp meter right here. Oops, let's see if my pen works. There we go. And we have the voltage across each resistor. So this is actually the same as the previous 2 problems. We're looking for the same information. We're just presenting it in a slightly different way, just graphically. Here, I think my pen wasn't working when I wanted to highlight the amp meter, but there it is. So the first thing I want to find is the current going through this amp meter. And to do that, I am again going to need to find the equivalent resistance. So to find the equivalent resistance, I simply have to add my 2 resistances together, 3 ohms plus 4 ohms. That's going to give me an equivalent resistance of 7 ohms. Once I know the equivalent resistance, I can use Ohm's law to find the current. I divide my voltage, 24 volts, by my equivalent resistance, 7 ohms, and that's going to give me a current of 3.4 amps. Now I have my 2 voltmeters that have to be wired in parallel to the resistors. Remember, voltmeters are always wired in parallel. Amp meters are always wired in series. So for the voltage across my first resistor, which is that voltmeter right there, I need to multiply my current, 3.4 amps, times the resistance of that first resistor, 3 ohms. And when I multiply those 2 together, I'm going to get a voltage of 10.3 volts. For the voltage across resistor 2, that voltmeter right there, I'm going to multiply my current, 3.4 amps, times the resistance of resistor 2, 4 ohms, and I am going to get a voltage of 13.6 volts across resistor 2. And again, if I add these 2 values here up, 10.3 plus 13.6, I'm going to get 23.9 volts, which again is very close to my total voltage across the battery of 24 volts. That's always a good way of double checking your work to make sure that you have done your calculations correctly. Problem 4. 2 resistors with values of 10 ohms and 15 ohms are connected in series as shown above. A voltmeter connected across resistor 2 reads 30 volts. Determine the current passing through the circuit and what is the voltage across the battery and across resistor 1. One quick note about recognizing whether a circuit is either a series or parallel circuit just by looking at the circuit diagram. Remember, in a series circuit, the electricity only has one path to follow. So in this particular circuit, the electricity, and I'm just going to draw this in the direction of conventional current, the electricity is going to come out of here and go through here. It has to go through resistor 1, then it has to go through resistor 2, and then back to the battery. There's only one path for the electricity to follow, which is what makes it a series circuit. So I know that the resistance of the first resistor in this problem is 10 ohms. I know that the resistance of the second resistor is 15 ohms, and the voltage across resistor 2, this guy right here, is going to be 30 volts. The first thing that they want us to find is the current passing through the circuit. So I know because it's a series circuit that my current is the same across each resistor and across the battery. So I need to know the voltage and the resistance going across either of the resistors or the battery. And I know on resistor 2, I know both the resistance and the voltage. So from that, I can find the current across resistor 2. So to find the current on resistor 2, I have to divide the voltage of resistor 2 by the resistance of that resistor. So 30 volts divided by 15 ohms is going to give me a current of 2 amps. So I know that the current for the entire circuit is 2 amps. The next thing they want us to find is the voltage across the battery. In order to find the voltage across the battery, I do need to know the equivalent resistance. And because this is a series circuit, the equivalent resistance is simply going to be the sum of the two resistors. 10 ohms plus 15 ohms is going to give me 25 ohms. And now that I know that the equivalent resistance, I can use Ohm's law to calculate the voltage across the battery. So 2 amps times 25 ohms is going to give me 50 volts. To find the voltage across resistor 1, I need to take the current and multiply it by the resistance of resistor 1. So 2 amps times 10 ohms is equal to 20 volts. Problem 5. 3 resistors with values of 3 ohms, 5 ohms, and 7 ohms are connected in a circuit as shown above. When the switch S1 is in the position shown on the diagram, only 2 resistors R1 and R2 are connected to the 36-volt battery and the current is I1. If the switch is moved to its down position and the third resistor R3 is connected in series to R1 and R2 and the battery, it produces a current I2. They want to find the reading of the amp meter, in other words, find the current for I1 and I2 for the two different switch positions. So for the first part of this, we want to find the current when the switch is in the upper position. So if we follow the path of the current, if we go across, up, through our R1, through R2, remember the current is going to follow a closed circuit. It has to have a complete path from one end of the battery to another. So you can see it bypasses resistor 3. So to find the equivalent resistance for this position, we need to just take into account resistor 1 and resistor 2. So the equivalent resistance for position 1 is going to be 3 ohms plus 5 ohms. That's going to give me 8 ohms. To find the current through for this position, I need to divide the voltage of the battery, which is 36 volts, divided by my equivalent resistance, 8 ohms, and that's going to give me 4.5 amps. For the second position of the switch is if we take the switch and we move it to this position right here. Sorry about that, hold on. So now if we trace where the current goes, again, using the direction of the conventional current, now it's going to go through resistor 1, resistor 2, and also resistor 3. And I don't know what happened to my little mark there, but it's going to go up to here and then to the battery. Let me put my little mark here for the switch in the down position. So now it's going to go through all 3 of the resistors. So to find my equivalent resistance for position 2, I need to take into account all three resistors, and my equivalent resistance is going to be 15 ohms. Now to find the current for this position, I need to take my voltage of 36 volts divided by my new equivalent resistance, 15 ohms, and I'm going to get a voltage of 2.4 amps. Problem 6. Resistors with values of 4 ohms and 6 ohms are connected in parallel to one another, and the combination is connected in series to a 36-volt battery. Find the current through each resistor and the power dissipated by each resistor. The first thing we should notice is that we are now dealing with a parallel circuit. And we know in a parallel circuit, the current is going to be shared among each branch of the circuit, but the voltage is going to be the same along each branch of the circuit. So I know in order to find the current through the first resistor, I have to take my voltage and divide it by the resistance of the first resistor, 4 ohms. So 36 volts divided by 4 ohms is going to give me a current of 9 amps through that first resistor. To find the power dissipated by the first resistor, I know power is equal to the voltage times the current. So 36 volts times 9 amps is going to give me 324 watts. For the second resistor, to find the current through that resistor, I have to divide the voltage 36 volts by the resistance of resistor 2, 6 ohms. 36 divided by 6 will give me a current of 6 amps through the second resistor. The power dissipated by the second resistor is going to be equal to the voltage times the current of that resistor. So 36 volts times 6 amps is going to give me 216 watts of power. Problem 7. 4 resistors with values of 3 ohms, 6 ohms, 9 ohms, and 12 ohms are connected in parallel to one another, and the combination is connected in series to a 24-volt battery. What is the current through each resistor, and what amount of power is dissipated by each resistor? So this is going to be solved similar to the prior problem. We just have 4 resistors instead of 2. So for the first resistor, I know that I need to divide the voltage by the resistance of the first resistor. Remember, the voltage is the same across each branch of the circuit. So 24 volts divided by 3 ohms is going to be 8 amps. For the power dissipated by resistor 1, I have to multiply the voltage by the current of resistor 1. So 24 volts times 8 amps is going to give me 192 watts. We'll follow the same procedure for the second resistor. So for the second resistor, or the current through the second resistor, I know the voltage, 24 volts, has to be divided by the resistance of the second resistor, 6 ohms. 24 divided by 6 is going to give me a current of 4 amps through the second resistor. And the power dissipated by the second resistor is going to be equal to the voltage times the current of the second resistor. So 24 volts times 4 amps is going to give me 96 watts of power. For resistor 3, I know the current through that resistor is going to be my voltage, 24 volts, divided by the resistance of that resistor, 9 ohms. 24 divided by 9 is going to give me 2.7 amps. And the power dissipated by resistor 3 is going to be equal to 24 volts times the current of resistor 3, 2.7 amps. That will give me 64 watts. And finally, for resistor 4, the current through that resistor is going to be 24 watts divided by 12 ohms. That will give me a current of 2 amps through resistor 4. The power dissipated by resistor 4 is going to be equal to the voltage times the current of that resistor. So 24 volts times 2 amps is going to give me a power rating of 48 watts. Problem 8. Three resistors with values of 5 ohms, 15 ohms, and 25 ohms are connected in parallel to each other, and the combination is connected in series to a 120 volt power supply. Find the current through the circuit as well as its total power consumption. So I know in order to find the current of the circuit, I am going to need the equivalent resistance. And because this is a parallel circuit, I know that the inverse of the equivalent resistance is equal to the sum of the inverses of the individual resistors. Now that's kind of hard to put into a calculator, so we're going to rewrite this equation in a calculator-friendly way. So now I know I can just put in the inverses of each of the individual resistors, add those up, and take that sum and take the inverse of that. When I do that, I'm going to get an equivalent resistance of 3.26 ohms. Now that I have the equivalent resistance, I can use Ohm's law to find the current of the circuit. So the current is going to equal the voltage, 120 volts, divided by my equivalent resistance, 3.26 ohms, and that will give me a current of 36.8 amps. To find the power dissipated by the circuit, or the power consumption of the circuit, I'm going to multiply my current times the voltage, 36.8 amps, times 120 volts will give me a power consumption of 4,417 watts. Problem 9. A 5 ohm resistor is connected in parallel to an 8 ohm resistor, and the combination is connected in series to a DC power supply. A 0.25 amp current passes through the 5 ohm resistor. What is the current passing through the 8 ohm resistor, and how much current passes through the power supply? In order to find the amount of current passing through the 8 ohm resistor, I'm going to need to know the voltage going across the 8 ohm resistor. And because this is a parallel circuit, I know that the voltage is going to be the same across all branches of the circuit. So if I can find the voltage going across resistor 1, I can then apply that to resistor 2. And because I know the resistance and the current of resistor 1, I can find the voltage of resistor 1 using Ohm's law. So to find the voltage of resistor 1, I have to multiply the current of that resistor times the resistance, 0.25 amps, times 5 ohms is going to give me a voltage of 1.25 volts. I can now apply that to resistor 2, and to find the current of resistor 2, I divide the voltage by the resistance of resistor 2. So 1.25 volts divided by 8 ohms will give me 0.16 amps. To find how much current passes through the power supply, I'm going to need to know the equivalent resistance. And again, because this is a parallel circuit, I know that the equivalent resistance, or I should say the inverse of the equivalent resistance, is going to equal the sum of the inverses of the individual resistors. And in my calculator friendly format, I take the inverse of the 5 ohm resistor, add the inverse of the 8 ohm resistor, take that sum and find the inverse of that, and I end up with an equivalent resistance of 3.1 ohms. Now to find the current passing through the power supply, I take the voltage, 1.25 volts, and divide that by the equivalent resistance, 3.1 ohms, and I will get a current of 0.40 amps. Problem 10, the last one. In the above circuit, two light bulbs L1 and L2 are connected in parallel to one another, and the combination is connected in series to a 120 volt power supply. The resistances of the light bulbs are 480 ohms and 360 ohms respectively. Find the reading of each amp meter shown in the circuit. So the first ammeter I'm going to want to find is the one that's going or wired in series with the first light bulb. So we can see that this ammeter here is in series with the first light bulb. So to find the current going through that light bulb, I'm going to use the voltage of the circuit divided by the resistance of that light bulb, 480 ohms, and that is going to give me a current of 0.25 amps. For the current going through the second light bulb, so there's my ammeter for the second light bulb. We can see that that is wired in series with that light bulb. I am going to divide the voltage by the resistance of the second light bulb, 120 volts divided by 360 ohms is going to give me a current of 0.33 amps. Now to find the current going through this ammeter, I'm going to need to know the equivalent resistance of the circuit. And I know that the equivalent resistance is going to be equal to, or the inverse of the equivalent resistance is going to be equal to the sum of the inverses of the individual resistors. So when I do that out, I am going to get an equivalent resistance of 206 ohms. Now to find the current going through the battery or for the entire circuit, I'm going to take my voltage, 120 volts, divide it by my equivalent resistance of 206 ohms, and that will give me an overall current of 0.58 amps. And once again, if we take a look at the current going through each of the individual resistors, 0.25 amps and 0.33 amps, the sum of those is going to equal the current going through the circuit, 0.58 amps.